Welcome to The Explainer. Today, we're going to talk about the invisible safety nets that keep our networks running, the protocols that stop one little hardware failure from taking down your entire office. We're diving deep into first-hop redundancy.
So let's kick things off with a scenario, one that's a nightmare for pretty much any network administrator. Imagine your whole company, your whole office, relies on just one router to get to the internet. Now, what happens if that single box suddenly dies?
Well, the result is simple, and it's painful. No internet, no email, no cloud apps. Work just stops. For any business today, that's not just an inconvenience, it's a catastrophe.
And that one fragile router is a perfect example of a really critical flaw in design, the single point of failure. Think of it like a line of dominoes, right? A single point of failure is that one domino that, if it gets knocked over, takes the entire line down with it. In any system, this is the one piece you absolutely cannot afford to lose without a solid backup plan.
And for most of us on our local networks, that crucial domino is almost always the default gateway. It's the very first hop all your data takes on its journey out to the internet. So if it goes down, everyone inside is completely stranded.
Okay, so how do we fix this? How do we build a network that can actually survive its most important piece failing? Well, the answer is a concept called redundancy.
Redundancy is basically your plan B. It's all about having extra gear, extra software just sitting there on standby, ready to jump in the second something goes wrong. It's about building fault tolerance right into the system from the start.
And you see this idea all over the place in the IT world. You know, RAID and servers uses multiple hard drives, so if one dies, your data is safe. Big servers have multiple power supplies. Businesses pay for backup internet lines. The goal is always the same. Keep things running no matter what.
So how do we bring this idea of redundancy to our gateway problem? This is where the real magic happens, with something called first-hop redundancy protocols, or FHRPs for short.
The genius of FHRP is that it creates this really clever illusion. You take two or more actual physical routers and you get them to work together so they look like one single ultra-reliable virtual router. They share one IP address, and that's the address everyone on the network uses as their gateway. One router gets elected as the active one to handle all the traffic, while the standby one just sits there, listening and watching. And that's the whole point, right? It's completely transparent. If that active router fails, the standby one immediately detects it and takes over that virtual IP address. To the people on their computers, nothing seems to have changed. Their gateway address is the same. They probably have no idea a piece of hardware just died.
Okay, so not all of these FHRPs are created equal. Let's take a quick look at two of the big ones you're going to run into out there, HSRP and VRRP.
Right off the bat, the biggest difference between them is who made them. HSRP, that's a Cisco thing. It's proprietary, so you're mostly going to see it on Cisco gear. VRRP, on the other hand, is an open standard. That means any company can use it, which makes it way more flexible if you've got a mix of different brands in your network.
So you might be wondering, how does that standby router even know the main one has failed? Well, in the case of HSRP, it uses these little messages called hellos. The active router is constantly sending out a little, "Hey, I'm still here" packet every 3 seconds.
And that standby router, it's basically got a stopwatch running called the hold time. If it doesn't get a hello message from the active router within about 10 seconds, it just assumes it's dead, and it triggers a failover, making itself the new boss.
Now this table lays out some key differences, and honestly, the details here matter a ton. You'll see VRRP is a bit faster by default, which means a quicker failover, but the most critical difference, the one you really have to pay attention to, is preemption. With VRRP, if your main, more powerful router fails and then comes back online, it will automatically take back control. HSRP, by default, won't. It'll leave the backup router in charge. That one setting can completely change how your network behaves after a failure.
So, let's zoom out for a second. Let's forget the specific timers and terms for a minute. What's the real point of all this?
At the end of the day, FHRP is about building that safety net. It gets rid of that single point of failure at your gateway. It gives you an automatic, totally transparent failover that protects your business and turns a fragile link into a resilient one.
And you know, this quote here from the source material just nails it perfectly. It's not just about having a backup router sitting in a rack. It's a systematic method for guaranteeing that your network can survive a hit without disrupting the people who rely on it every single day.
And that kind of leaves us with one last thought, doesn't it?
This whole idea of finding that one weak link, that single point of failure, and building in redundancy is just so powerful. Sure, it keeps our networks online, but it applies to so much more. It really makes you wonder, where else in our systems, or even in our lives, do we need a better backup plan?